Hello and welcome to this Lufft Academy webinar with the topic MARWIS in Action Applications with the Mobile Road Sensor. My name is Tobias. I'm the technical support today, and before I give the word to our CEO Klaus Hirzel, who will be the moderator today, I want to invite you to ask questions. All the time you can ask questions. We want to have a lot of questions from you, and you can do this by using the chat function of our webinar. You should see that on the right side of your screen. So now it's time to give the word to our CEO Klaus Hirzel.
So welcome to the MARWIS webinar today. Thank you for your time. We intend to keep that as short as possible, 30 minutes of your time today, not longer. And please use the chat function to interrupt us, and we will immediately try to give you answers concerning your questions. So we want to start with a few general remarks. If we can just see the new title of our MARWIS brochure, then you see two things. You see technology and you see applications. Well, today we all have overload of informations. Every day you receive hundreds, tons of emails. You have options to download terabyte of documents. And so how to find the right things? That is one of our key challenges in our information-driven society today. So far we had the application of information both offline and online. So if you visit Lufft.com, then you see a lot of technical details such as resolution, measuring ranges, protocol integration, calibration features. You see all the technical details, how to manage our sensors, how to manage our components to make it a solution at the end. So now we have decided to walk away from this technical part in our print literature. The MARWIS brochure has been redesigned now, and that is the first example of how we see additional value to all your activities in future by having complementary information in that print literature. So if you compare our online and our offline information, then please see online as what we have today in terms of all the information in detail. And if you study our offline, such as a MARWIS print, then read it as a book. So it is not only valid today, so we think it is useful for you, it is useful for your users over maybe the next years. We will certainly redesign it, add more content, but at the end it will be fully application driven. If you see the MARWIS, then you have a weather critical operation behind that product. So we all came from meteorological applications, making sensors for understanding weather conditions, doing, let's say, the right measurements for having precise forecast and nowcast information. If you see MARWIS, then that is more operations driven. Something has to be done, decided to make a road safer or a runway cleaner. So weather critical operations, that expression has been invented by Vasala. I personally like this because that shows it has to be real time and we have to support decision-making processes. So weather critical operations in that case has to do with traffic weather. Traffic weather with the MARWIS has to do with roads and runways, not so much with ships and not so much with trains. But whenever you see asphalt, whenever you see a plane touching down, so maybe a MARWIS helps to have a safe arrival. So if you see this brochure, please think in weather critical operations and traffic weather, road and runways, and then see the applications behind which we want to study in greater detail right now in the next minutes. So we want to start with a little introduction before we open the double pages in our literature. Well, whenever we have a business, there's a reason for that business. Of course, that is a business because we meet a business partner. Let's say we call our business partner a customer. So that customer asks us to come because he expects help from us. First of all, whenever someone needs help, there is certainly a pain. It's not necessarily a significant, a severe pain, but there is something we might be able to improve. If we don't find a win-win with our customers, so it's better for us to go and to leave, because if the customers have no pain, have all fully optimized, so what to do with this customer? Just to talk about technology? No, we want to help. And that is why we love to talk about benefits. Benefits first is to improve safety. But of course, we also talk about cost optimization, how to cut the costs, how to reduce the costs. At the end, the MARWIS is very often driven by allocation of public money. So if the taxpayers' money needs, let's say, a good reason to be spent, then we have to justify what are the benefits of a MARWIS in that case. Now, we don't need a doctor every day, fortunately, but from time to time we need improvement. And if you see that from a weather standpoint, so we will all experience more weather extremes in future. The climate change will give us more surprising weather. Here in Germany, end of April, we had snow this year. We had no snow in January, nothing in February, and at the end of April, which is the second spring month here in Central Europe, is where snow came in and destroyed a lot of the crops in Austria. A lot of grapes and a lot of apples were destroyed, caused by that late winter arrival. So what is the pain which we want to help out with the MARWIS? So if you see some of these pictures, that might stand for a few examples. It certainly does not cover all the pain which we see right now, but traffic, of course, has to do with weather conditions. And it's not only to talk about cars and to talk about runways, it's also to talk about bikes and bikers. That is why we really show that picture, because now in many environmentally friendly European cities, people use electric bikes. That means they are high-speed bikers. So the average speed in Amsterdam is 40 kilometers per hour, pretty speedy. And I mean, they are used to go with the bikes 365 days each year. Now, the pathway for the bikers is totally different to a runway or to a roadway or to a highway. So the thickness of the asphalt layer is thinner than the thickness on a runway or on a secondary road. So the risk of seeing ice formation starts earlier than on the road itself. So don't believe that if the car is safe, that the biker is safe. No, they drive under different circumstances. That is why a lot of cities start to detect the risk of ice formation on the pathways of the bikers. So they start to use non-invasive technology to see, is that ice formation already begun? So if you see now there's a risk of accidents, there is not only a winter-related risk, it's also a water-related risk. We very often forget that in our place where we live. We think, well, all has to do with the friction risks caused by winter conditions. If you go to tropical countries and then you see the climate change which today produces a lot of additional rainfall compared to what they had 10 years ago. Now maybe 300 to 400 liters per hour in a few extreme cases, whereas in 10 years ago it was only 200. So that doubled, and that doubled also the risk of having slippery conditions. A 747 needs 2.5 kilometers in length to stop the plane. The longest runway is 4 kilometers. You can imagine if that there is a tropical rain shower and that causes slippery conditions, so that can easily double the distance to stop the plane. That is why if you have a short runway and if you have tropical conditions, so sometimes the pilots, they sweat before they try to touch down. At the end, they need information technology to understand it's better to wait another 5 minutes before touching down, because all these extreme aquaplaning risks, they come and go. That is not a long-standing event, that is a short-standing event. So maybe in 5 minutes it's over. But during that 5 minutes, so no plane should be allowed to touch down. So we don't cover all the pain, but a last pain I want to mention here is the critical travel time conditions during winter time. Of course, everybody wants to be safe and wants to have reliable understanding of arrival time. We have so many appointments today, and if we promise to be at our customer's location tomorrow morning at 10 o'clock, we have to be there at 10 o'clock. Otherwise, we have no time slot anymore for us. So what if we arrange that under critical winter conditions, say, okay, I leave my hometown at 7, but at that special day, I need not 2 hours, but 4 hours to arrive at my customer's location. I can cancel the trip before I go because I just miss the time slot. So travel time calculations and reliable travel time recommendations, that is another key target for improving the operations. I think that was enough to talk about doctors and pain and win-win and benefits. We of course prefer to discuss how we can improve operations, how we can make things better. And so far our company slogan is passion for precision. I think that is not enough anymore. Precision is needed, yeah, passion is required, but we want to understand how to improve operations, how to help application understanding to be sure that, let's say, proactive management have been started to avoid de-icing conditions. So the Lufft part of what we can do is innovation driven. We want to change status quo. We want to find better ways to help making proactive decisions. So innovation is our key. However, innovation does not stand for itself. We have to understand the application behind. That is, we work on technology, but we want to understand what you need, what the customer needs, and that is what we like to describe in imagination. At the end, we want to combine the two things. So we want to listen to customers. They tell us what they need. We bring all their requirements into our innovation management. Our engineers, they study applied technologies. They understand ultrasonic technologies, radar, capacitive, laser, spectroscopy. They understand what technically can be used to make better sensors, long-term stable technologies, longer life cycles. So both things together will work out pretty well in our opinion. So if we look into a result of our ways of thinking, then we can see a first picture of the MARWIS, a first double-page description. And I personally don't like so much the law. I'm rather interested in making new things and accepting a risk which is related to new things. Every change of status quo has a certain risk factor integrated. As long as we understand the limitation of the risks, because we know what we have done in the past and we know what we intend to do, that means we just continue to do the same what we have done in the past. So we, I think, have a certain limitation that we avoid to have too much risks with innovation processes. But our application people, they have risks also. If they make a decision and the decision works out well, everybody's happy. But what if that decision is, let's say, too late, decision has not done appropriate enough, so then they have to justify why was that decided? So what was the background of that decision? Now you need data. You need a lot of documentation. So you need to have a proof of what was decided, why that was decided. Right now there is a lot of gaps, data gaps in our road weather networks. If we see what we really need, we need a complete picture of our province, of our area, of our city to understand, is that bridge critical? Is that bridge frozen? Is that bridge safe? What about that part of the roads which are close to downtown? So we need a full picture of road weather conditions in that area where we are responsible for. How to make that with only fixed sites? It's a difficult approach. If you have fixed sites and the fixed sites are a certain investment, so some people can afford to install every 5 kilometers a fixed site. Others, they only do that every 50 kilometers. In both cases, you have gaps in between. So if you combine fixed sites and mobile technology, then you get hundreds of additional data through your winter trucks whenever you have winter conditions. As long as that's dry, the fixed sites are good enough to give you enough weather forecasts. But whenever you have that critical winter day, that critical event now approaching your territory, then you can use a complete picture to make your decisions. We have displayed here a software piece that is just one example how that can be presented. So we believe in open world. We think that in most of the cases there are different specialists working on different elements of such a solution. We are sensor manufacturer, we are driven by technologies. We want to make the best environmental sensors worldwide. That is our mission statement. There is a worldwide coverage which we can use to give the data as real-time information into a data cloud. So data loggers are in use today, but maybe in future not so needed anymore. Here in Europe, we have GPRS and we have Wi-Fi and Bluetooth and all these wireless communication technologies. There's a new technology on the way called LoRa, and LoRa will only cost €1 per month per station to transmit data into the data cloud. So that will help to have reduced cost factor per month for real-time data everywhere, anytime. So we think if you have open world and you combine smart sensors with smart communication technologies, cheaper than 10 years ago, if you combine that with data clouds where you store the data in your just content-oriented databases, and then you have people working on user interfaces, on user-friendly software to manage the big data and to give you your decision-making background. Then these are the different elements which make a user-acceptable solution. That is what we want to show here. First of all, you have the big data, you have possibilities now to have a clear picture of the complete province, of the complete territory, and all the software interfaces in future will have a need to combine fixed sites and mobile sites. So we love, I mean, we are Germans, but we love English very much because that is so short. So I don't know how to say that in German with 2 words only. So Americans and English people, I think they have invented to give a clear message with 2 words only. I mean, our engineers work on technology. However, we have to make sure that the technology is in the application's favor. This is why we have to address that, to say user first. If users have requirements, we really listen. Every company promises to listen, but we have established an innovation management in our company, and innovation management has 2 inputs. The one comes from our engineering department. We call that applied technologies. Whenever they find new ways to measure relative humidity in a better way, avoiding drift over time, for instance, then these technical ideas come from our think tank. However, whenever we receive application-driven requirements, that comes from users, that comes from decision makers, and they tell us what they expect from us, how to make a sensor more application friendly, how to make a software piece easier to be understood. So our innovation management addresses the 2 inputs parallel, and with these 2 different inputs, we want to help you and the customers to optimize instead of maximize. So that brings us to the second content page, which we have here. So that is not to talk about having a proof of all the data to justify what was done. That is more to talk about optimization. How can we change the way of thinking? How can we work on more efficiency? And so there are 2 different ways of thinking. The one is how can we increase safety, and the second is how can we reduce expenses. So we believe that with the right information technology, we can, together with the application people, reach both targets parallel. Today, a lot of people want to be safe, and whenever they don't know exactly the conditions, then they maximize the output of salt, for instance. So they want to be safe, I would do exactly the same. But what if a salt spreading truck has a sensor knowing exactly how the surface is structured right now, to understand water film in micrometers, to measure the ice percentage, to know the friction, to know the road temperature, and maybe even to know what will be the road condition in 2 hours from now at that location where the salt spreading truck is. So that is all possible today with smart sensors. They communicate with the cloud, and they communicate with the controller of the salt spreading truck. The driver can concentrate on safe driving, and the controller and the MARWIS, they talk and negotiate what is the right percentage of salt which has to be spread under the given circumstances. So that is optimization. The other benefit is do it proactively. So start the icing before it starts freezing. And freezing is not a 0-1 event. So that is a slowly changing condition where you can imagine like a traffic light that is red, yellow, green. Green is friction is good. Red is definitely too late, but if friction is around 0.6, it starts freezing. It's still good enough to drive, but if you act now, you proactively act. If you start doing that at 0.5 or less, it's definitely too late. So here we want to help to be more proactive with the salt spreading actions. We want even to help with the MARWIS to do a dynamic routing of the salt spreading cars. So dependent on where road conditions are critical, not just following the typical plan which is distributed to the drivers before winter season starts. Every day is different, every action is different. If we understand the microclimate data, then we can even optimize the routing of the trucks. There are 5 minutes left now for us to look a little bit ahead of our time, and I mean future now is really fast. So if you see our digital century, then you see highly dynamic technology changes. So we cannot foresee what will be in 20 years, not even in 10 years. But I think we can expect a few of the things which will be part of our life. So for instance, in 10 years, we will sit in a driverless car. Maybe not in a crowded city, but let's say if you travel from coast to coast in the United States using a freeway, I think so the robot will do the job and we can sit and listen, relax to music or do some telephone calls, and once the robot is not able to drive anymore, he will let us know. So why MARWIS with a driverless car? So a driverless car needs a lot of sensors built in. So there is a camera, there is a distance sensor, such as a radar, that the cars are connected in the region where they all drive, they share information, and the cars receive a lot of data from data clouds, and all these redundant information together, they will allow cars to do driverless driving. So a big issue for car manufacturers today is how to measure friction. Most of the driverless cars today have been tested in California. There is no weather, or it's only one weather. It's sunny and dry, but it's not ice related, it's not too much water on the road surface. Now a lot of car manufacturers have studied in the last years how to measure friction in a car. They used a laser and found out that is two-point oriented. It is not representing the road, so it's just a point. We cannot use a laser for that. Then they started to work with high-speed cameras to understand what is below the car. And the camera itself was not good enough to measure a water layer in micrometers. So they all came back to spectroscopy, the technology which the MARWIS uses. That is representing not only a spot, but a representative size of the road, and we really detect in micrometers water films and water levels. Now most of the car manufacturers use the MARWIS as a reference sensor against other friction meters. So they need to understand first what can a spectroscopic sensor do to make a driverless car really driving reliably whenever there is a water layer detected. So that is a very initial stage. Our key target in these industries is that they see the MARWIS as a reference sensor for friction, not to go into a car as a friction sensor. For that is not compact enough and far too expensive, but they all use that as a friction reference. So that is the key which we see in that industries. And a last word about the last page before we stop. So the short-term vision is certainly how can the MARWIS help to have good friction understanding in a driverless car. The long-term view is what is the way to avoid any accident caused by slippery conditions. So how to optimize travel time for each driver, and how to understand the weather completely each meter to avoid any weather gaps. So a driverless car can drive safely if the asphalt is good enough. So there has to be winter services active before the driverless car starts driving. So proactive management of all the critical roads and runways, that is needed. And if you understand each meter with big data, and that gives us now maybe a reason to have a look into the last page of our MARWIS site. So if you see the big data aspect with the MARWIS, it's a little bit similar to Google or a little bit similar to Amazon. So the first wins most of the market shares. So Google is a good example for that, Amazon as well. Here we talk about traffic weather data. Imagine if you have a fleet of mobile cars, of cars which are out 24 hours per day, collecting road condition data, sending these data into a data cloud. That is a great value for decision makers. So the DOTs can use, Departments of Transportation can use this information, driverless cars can use these informations as well. So this is our future-oriented outlook, to say the one who starts selling big data to the industries first, to decision makers, to driverless car industries, they will certainly have a quite interesting business model by using this mobile data in addition to fixed sites. So now we have 4 o'clock and we have a few questions, right?
Right.
So we will share the questions with you. So question 1, is there any plan to take the explosion-proof testing hazardous material transportation vehicle as a potential market combining with the voice alerting function of the app? Right now there is no plan to do it. However, it is correct that that is an interesting approach. So technically certainly possible, but that requires very low voltage of the MARWIS. Right now we have 12 volts. We certainly would have to bring then the power consumption down to a lower level with a totally different housing. So we see the MARWIS today as just the first construction where we equip existing petrol cars, we equip then some snow plowing trucks. If there is a requirement to equip, let's say, a fleet of explosion-proof cars as well, then that will certainly give us a reason to look into a revised construction.
Next question.
By MARWIS gives maximum friction value of 0.82 when the range is between 0 and 1. That is a correct and reasonable question. So in the real world, so far we heard that, let's say, the perfect condition is 0.82, that is not 1. However, other people told us, no, in some cases that's even 1.1. So we will bring that into our innovation management. And I fully agree with that question. So we have to consider to open that range to 1 as well, because if that is perfect, and perfect means we have the shortest distance to stop a car under perfect conditions, then maybe 1 is a reasonable output as well. For us, let's say it's more interesting to see the yellow and the red color of the friction conditions. So as long as that is 0.82 or 1 for us, from an application standpoint, that is the same, no difference. So it seems to be more interesting for us whenever friction declines to 0.7, 0.6, 0.5. However, we will check that. With the new sensors at the new MARWIS, are there new road conditions? Well, what we have done with the MARWIS 2.0 was now to offer a real air temperature measurement and a real relative humidity measurement. The road conditions have to do with the transmitters and with the receivers, with the LED light only. The temperature, the surface temperature, is just used in the algorithm to qualify the light absorption information. So at the end, the answer is there is no change of the road conditions. That just gives you additional air temperature and relative humidity information. We have a few countries they work on so-called ice cars. And the ice cars, they need to be a mobile weather station, including air temperature and humidity, sometimes even solar radiation. And these industries and these people, they want to use air temperature and humidity in addition to the road conditions. No more questions?
No more questions.
Thank you for your time today. Sorry, we were a little bit over time, 5 minutes over. Thank you. Whenever you have more questions, please contact us as usual through email. And thank you for your time today.
Bye-bye.
Bye-bye.